Welcome to SkyWeek. I'm Tony Flanders from Sky and Telescope magazine, and I'll be your guide to the astronomical wonders that are currently on display overhead. Let's see what's happening in the sky from Monday, February 24th to Sunday, March 2nd. The waning crescent moon is visible in the southeast before sunrise, upper right of Venus. It's closer to Venus on Tuesday and quite close to Venus's lower left on Wednesday. A very thin crescent may be visible well to Venus's lower left 45 minutes before sunrise on Thursday. The moon reappears in the evening sky on Sunday as a super thin crescent low in the west after sunset. Mighty Orion flies high in the early evening. A sword of 3 or 4 stars hangs below his belt, and keen-eyed observers can see a tiny cloud of light around the next to bottom star. This is the Great Orion Nebula, which is giving birth to new stars even as we speak. In binoculars, it's small but easy to spot, and through a telescope, it's one of the most glorious sights in the heavens, dazzlingly bright and intricately textured. The Orion Nebula contains enough gas to make 2,000 sun-sized stars, and it's spread out over 25 light-years, 150 million times the sun's diameter. That's inconceivably sparse by everyday standards, but extremely dense by cosmic standards. 3 million years ago, the nebula was an inert cloud of gas and dust. Then, at some point, clumps inside it became so dense that their own gravity started to compress them. Once that starts, the process snowballs. As the clumps shrink, their gravity gets stronger. The clumps draw in material from the surrounding nebula, making their gravity stronger, and they shrink even faster. When you compress gas, it also gets hot. So these protostars, as they're called, begin to glow. Once a protostar reaches 18 million degrees, it ignites. Hydrogen atoms start fusing to form helium, releasing huge amounts of energy, and the protostar becomes a true star. The Hubble Space Telescope has imaged protostars in the Orion Nebula and elsewhere. What you're actually seeing are the disks of matter surrounding the protostars. They're called protoplanetary disks, or proplyds, because they're thought to be similar to the disk that gave birth to the planets in our own solar system. Protostars are a battle between gravity pulling material in and heat pushing it away. Often they shoot intense jets out along their spin axes. Once the star ignites, heat wins out against gravity, at least until the star's fuel is used up. Anything inside the protoplanetary disk that hasn't condensed into a planet or planetesimal is blasted away. In fact, the entire nebula's days are numbered. Theta 1c, the brightest star inside the Orion Nebula, puts out 200,000 times as much energy as our Sun, mostly in the form of ultraviolet radiation. It's that UV that causes the entire nebula to glow like a neon light. It's also eroding the nearby proplyds, preventing them from evolving into full-fledged stars. It has already blasted a hole in the main nebula, and it's only a matter of time before the entire nebula is blown away, leaving a cluster of young stars. Most, if not all, stars are born in clusters. Very young star clusters, like the one inside the Swan Nebula, can be seen in infrared but not in visible light. They light up the nebula, but all the light from the individual stars is blocked. The Orion Nebula is an adolescent. We can see both the stars and the nebula. And in a mature cluster like the Beehive, all the gas is gone and the stars shine unimpeded. Next week, we'll talk about Jupiter. Until then, this is Tony Flanders from Sky and Telescope magazine, wishing you clear skies and great views.
Brought to you by Woodland Hills Camera and Telescopes, serving stargazers since 1952.